We're in section 6.3, working with phase angles. A phasor consists of a vector that can be rotated around a central point. And so here is our phasor, and it could be rotated around the central point, which is right here. The length of the phasor corresponds to the peak value of the sine wave. So here we have this phasor is going to represent the peak value of the sine wave. So if we had our sine wave, okay, this is not a real well drawn sine wave, but we would have a peak value right here, and we would have another peak. The negative peak would be here, and the length of the phasor corresponds to this peak value. The angle of the phasor corresponds to the instantaneous phase angle of the sine wave. So the value that we would be considering here is going to be the instantaneous value, and that's going to be based on the phase angle right here. And remember that we started out at 0 degrees, and this was 90 and 180 and 270 and such. And remember that if we want to calculate the different values at the different phases, those would be representative of the instantaneous values. And say we picked off, well, let's just pretend we pick off one right here, and let's say that is 45 degrees. So the angle would be 45 degrees, and we would be interested in what is the instantaneous voltage at 45 degrees given a peak value of whatever the peak value is. Okay, so here we have a phasor. The question is, what is the peak voltage? And looking at this, we can say, well, the phasor represents the peak voltage, so the peak voltage will be 100 volts. And what is the instantaneous voltage? And so here we have this value, 50 volts, and that could be drawn down like this. That would also be 50. So the instantaneous value would be 50 volts, and the phase angle here would be 30 degrees, and that's just reading what do we have in this block of information. Okay, right triangle relationships. A dotted line is drawn from the point of the phasor to the horizontal axis. This forms a right triangle. So from right here, the point of the phasor down to the horizontal axis, and we have a right triangle formed by that relationship right there. Side A is a portion of the horizontal axis. So side A here is a part of the horizontal axis. Side B represents the instantaneous voltage of the sine wave. So that would be this right over here. This would represent the instantaneous voltage at a given angle. The angle of the sine wave is represented by this symbol right here, which is the Greek letter theta. And so that represents the phase angle. Side C represents the peak voltage of the sine wave. So this right here, this represents C is the peak voltage. A triangle drawn in this way will always have a right triangle, 90 degrees, right here, where B intersects the horizontal axis. Basic trigonometry is used to solve this type of problem. So here we're going to look at right triangle relationships. Okay, the first one, here we have a triangle, and the hypotenuse is the longest side and across from the right angle. Okay, so here's the right angle right here, and the hypotenuse is directly opposite the right angle. The angle represents the phase of the sine wave. Okay, so here we have, this represents the angle of the sine wave. The two sides are named based on their relationship to the phase angle. So here we have the phase angle right here, and the adjacent angle A is so called because it is adjacent to this angle, and then the opposite is so named because it is directly opposite of the phase angle. Sine, cosine, and tangent, these are calculator functions, are used to solve for these values. Phasor problems are solved using trigonometry, and this is getting into right triangle relationships. And we have, there are three basic equations used to solve phasor problems, and they are the sine, the cosine, and the tangent. And the sine angle has to do with the relationship or the ratio of the opposite side to the hypotenuse. Cosine has to do with the ratio of the adjacent side to the hypotenuse, and the tangent has to do with the opposite side to the adjacent. And one of the mnemonics that you can use to remember that is this little phrase right here: Sally can tell, and that's for SCT. Oscar has a hat on always. Okay, well, you can make up your own if you don't like that one, but that is a mnemonic that would help you to remember that relationship. Calculator operation. Scientific calculators contain tables for calculating sine, cosine, and tangent. If you key in the angle and the appropriate sine, cosine, or tangent, your calculator will yield a corresponding code. And so let's right after, let's see, in your text right after trigonometric functions, there are a few practice problems. Let's do just a few of those just to get the feel for this. Let's see, the first one they mention is the cosine of 28 degrees. So what we would do, we would enter in 28, and we would say the cosine, and we get this value 0.882. Then we have the next one is actually in radians, and if you're going to do that, you'll need to go to your options here and change to radians. And so here we have the sine is 3.6 radians, so let's go 3.6, and we'll do the sine, and the value is a minus 0.442. Now if we'd done that in degrees, that would be a different value. The next one is tangent of 150 degrees. Now what you need to do, it didn't specify radians, so we need to go back and change this to degrees. And so then our value is 150, and we're looking at the tangent. So that's going to be a negative 0.577. We'll just do a couple more here. Sine of 20 degrees, so let's see, let's key in 20 and sine, and that would be 0.342. We'll do one more tangent. It's going to be 175, and the tan function, and that will give us 0.087. Now there's 5 more. I'm going to encourage you to do these, and the answers are at the very end of the chapter, so please do those. Okay, inverse trigonometric functions. Now, this is the case where we know the sine, cosine, or tangent, but we do not know the angle. The function we want here is the arcsine, arccosine, and arctan. Arc means angles whose. So the expression arcsine 0.8 means the angle whose sine is 0.8. And so there are some examples, and I just want to do a couple of these down at the bottom there. Let's see, let's bring our calculator back for a moment. And so the first one is the arcsine of 0.7. So let's go over here, and first of all we'll enter in 0.7, and then we're going to press the shift key, and then we see the arc cosine, and you'll see that it is 45.573. Now with different calculators there might be a second key or something to indicate a second function, and usually you'll press the same key, only it will yield the second function. In this case it is the arc function. Okay, the next one is the arc cosine, And so the value we have is 0.633, and this is a negative value, and we want to get the arc cosine, and the value is 129. The next one is the arc tangent. We're going to be doing 0.466 and shift, and we want the arc tan, and that value is 24.9. Let's do just one more, the arc sine, and this is going to be of the value 0.0872. And we want the arc sine, and so here is the arc sine, and that's indicating 5. And these would all be degrees that we're looking at. Okay, phasor calculations. In the next section, I'm going to stop here. The next presentation, I want to walk through the practice problems at the end of this particular section. So this will conclude. We've looked at inverse trigonometric functions. We did some calculator problems. We looked at the sine, cosine, and tangent. We looked at a mnemonic to remember them. We looked at right triangle relationships. And we considered phasors. And the subject is working with phase angles. In the next section, we'll be actually solving some problems with them.